Alright, so this could be our next notes. This is going to be section 4.1 as you see here, and it's going to be angles of triangles. So now in these next few units we're going to be looking at proving triangles a little bit, how do you figure out angles of triangles, and subjects like that. So the first thing we're going to look at is just a general overview of triangles. And there's this, we're going to start off actually by proving certain things about triangles, and one of the ideas that you should all know is this idea of the sum of all angles of a triangle is equal to 180 degrees. A proof of that, or to write that out, if we had a triangle, like over here maybe, doesn't have to be a perfect equilateral or anything, it just says there's A, there's B, and there's C. So if we had these angles A, B, C, and these points A, B, C, probably be better, it'd be angles if they were on the inside, but if we just move this, made this A, then these points A, B, C forming this triangle, and we looked at each one of these angles on the side of these letters, we would see that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. And they call that the triangle sum theorem. Now going along with this idea is something called an auxiliary line. Okay? And what an auxiliary line is, just like an extra line segment used to help analyze geometric shapes. And we're going to kind of start using this a little bit. And you can use it to prove the triangle sum theorem. And if you look at this here, this triangle, we have this triangle CAB, and you make a parallel line here, this line AD, or this line D even, and it's parallel to CB. Okay? And then we can use that auxiliary line to prove that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. And we're going to kind of do that in a example here next. So an auxiliary line is just a parallel line you'd put parallel to some other line on the triangle. Usually works like certain places better than others, and I'll show you now how you use that. So here's our example, and this is going to be a column proof here we're doing, and you can see here that we have line, you measure the CAB, and inside we have angles 1, 2, 3, and on the outside we have angles 4, 5. And we use this auxiliary line, other things we've already learned about lines and angles in the last chapters that we did, and we're going to use that to prove that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. Okay, so how we use that line is the following. So we start off always with our given. So we have the given, the measure, or the triangle ABC, and then we're going to add that auxiliary line here. Okay, right here. So this is going to be our auxiliary. I'm just going to put AUX. And then we know the parallel postulate. So if this line is parallel to that, then we know certain things are true. Because of this parallel postulate, then, we can say that if we draw a line AD through A parallel to BC, then it's parallel. But then we can use that idea to say that the measure of angle 4 plus the measure of angle BAD is a linear pair. Actually, let's stop. Isn't too far. Alright, this is going to be our next unit. It's going to be on triangles. And we're going to look at figuring out angles. We're going to look at proving triangles. We're going to look at comparing triangles based on things like their sides and their angles and so on. It's not an exceptionally long unit. We should get this done and maybe another one done before we go away for Christmas. We'll have to make sure we're working hard and so on. Make sure you're getting the notes each night, ready to come into class and ask questions and do your homework. So the name of this unit, 4.1, is Angles of Triangles. One thing we should always remember, probably everybody knows this, you learned this in probably pre-algebra, is that the sum of the angles of a triangle is equal to 180 degrees. If we wanted to state that in a more mathematical term, or mathematical way, we could say the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. That is also called the triangle sum theorem. You can points here, right there. And if we look at this triangle here, that's what we're talking about. If we have point A, B, C, then we can call each one of those points angle A, angle B, and angle C. We would say if we add them up, they would be equal to 180 degrees. Now, a triangle by itself, we know they all equal 180 degrees, but there's other things we can use to figure out the exact angles of a triangle if we know one or two. And one is SOHCAHTOA. We're not going to do that today, but we'll eventually look at that. But an important part of this is something called an auxiliary line. You can kind of see it down below here. But an auxiliary line is an extra line segment used to help analyze geometric relationships. We base this on some of the theorems we've learned before. And you can see here, we're going to actually prove the triangle sum theorem in the next page here by using this line that's parallel. Okay, so our first chore using this auxiliary line, and the thing you have to remember is you have to assume, or it goes without saying, that this line D that we've drawn parallel to CB is going to be parallel. And that'll help us form 180 degree or supplementary angles. Sometimes it'll even help us form 90 degree angles. And we will talk about that in just a few seconds here. But here we're going to prove the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees by using that auxiliary line. So if we look at this, we're going to do a statement proof here. We start off with this idea. We have this triangle with BAC points on it at angles 1, 2, and 3. And then we have this parallel line, D, that gives us angles 4 and 5. We're going to have a given that you have triangle ABC, so that tells us they're all equal to 180, right? But we want to prove it now. So the measure of angle 1 to the measure of angle 2 to 3 is equal to 180. Now we know that's true if it's not a triangle, right? It's just a statement that we know is true. But let's go ahead and look at this now. So the first thing, if you remember, is what you're always going to write what you're given. So really we're given that we have a triangle ABC. Okay. Another thing we're also kind of given is that we have this parallel line here, D. So we can then use that next. When we're using this auxiliary line, we're going to say line AD is parallel to BC. So we have this line right here, this line on the top. We have to assume, we have to say that if we're putting this line in here, that it's parallel to BC. Okay? So, and that's the parallel postulate. And because these lines are parallel then, we can then use some of these rules about angles to help us prove something about this triangle. So if we go to number 3, we would then say angle 4 and angle BAD are a linear pair. So we come back to this triangle. So we're looking at angle 4, this one right here, and we're saying when we group that with this angle BAD, that they're a linear pair, or they form a line, right? And we can see if we add the angle 4 and the two angles of BAD, 2 and 5, we would see we form 180 degrees or a line, right? So that kind of gives our third reason. But then we also should remember that if this is a linear, these three angles are linear angles, they equal a line, that they also equal 180 degrees. So that would actually be our statement 4. We could restate that, and we could say the measure of angle 4 and the measure of angle BAD are supplementary. So that linear pair are supplementary, and then we can define that supplementary and say the measure of angle 4 plus the measure of angle BAD equals 180 degrees. So we're kind of getting on track here. And then we're going to use some other postulates to help us prove this. But we've got to 180 degrees now. So we started off with just this triangle, and now we've introduced the idea of 180 degrees. But you'll see one of the angles, two of them, 4 and 5, aren't even in the triangle, right? So if we look up here, so these angles, 4 and 5 that we're using right now, they're not even in the triangle. The only one that's in the triangle so far is 2. So if we go back to that, this is the one we just said. Angle 4 plus the measure of angle BAD equals 180 degrees. That's a definition of a supplementary angle. Okay, and then we're going to do something here, and we're going to say that the measure of angle BAD, what are the two angles then? So measure of angle BAD is the measure of angle 2 plus the measure of angle 5. So we're saying BAD, right here, it's angle 2 and angle 5. So if we add these two angles together, we get the measure of angle BAD. So that's kind of our next step. Those two angles together equal the measure of angle BAD. Then we're going to substitute those into there. So we're then going to say the measure of angle BAD is going to be, if we look, measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 equals 180 degrees. So we're going kind of back to here, 5, where we have the measure of angle 4 plus the measure of angle BAD equals 180 degrees. We're then in 6, we're defining what the measure of angle BAD is, 2 and 5, and then we're going to plug those in substitution-wise for the measure of angle BAD. So then we have measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 equals 180 degrees. So we substituted the measures, those two angles, for a measure of angle BAD. Then we're going to go to something that we learned, I don't know, maybe a couple weeks ago, this alternate interior angle theorem. Okay? And that says angles that are the alternate interior angles are equal to each other. So if we go back to our triangle and we see angle 4, the alternate interior angle would be 1. So they're equal to each other according to that theorem. And if we go to 5, we would then say angle 3, the alternate interior. So the interior, this is the alternate. It's going to be the inside one. This one's outside. This one's inside. This one's outside. 4 is outside. 1 is inside. So according to that theorem, angle 4 and angle 1 are congruent, and angle 5 and angle 3 are congruent. Now this is only true if this is a parallel line to BC, and we've already stated that it is. Okay, so then we go back to that, that's 8, and we would see that the measure of angle 4 is congruent with the measure of angle 1, and the measure of angle 5 is congruent with the measure of angle 3. Really though, if they're congruent, and that's the alternative interior theorem, then we would just say the definition of congruent angles says they're equal to. Not only congruent up here, but they're equal to. So the measure of angle 4 equals the measure of angle 1, and the measure of angle 5 equals the measure of angle 3. And if you remember, we started with this measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 is equal to 180 degrees. We can now plug in, since 4 and 1 are equal, we can plug in 1 for 4. So instead of saying here we had 4, now we say the measure of angle 1. We already had 2, so measure of angle 2 will keep it, but then 5, measure of angle 5, since it's congruent with 3 and equal to it, we can then plug that in, and we get the measure of angle 3. So then total we have measure of angle 1, measure of angle 2, the measure of angle 3 equals 180 degrees. We substituted that in, and we've proven what we wanted to at the beginning by using this parallel line and some of these alternative interior theorems and congruent angle theorems. So that's an example of how you use that to prove triangles are congruent. So if we go to the next thing here, another idea we have to learn is this idea of exterior angle theorem. Okay, so this is, if we look at, we can kind of first look at the theorem. We'll look at this triangle here. So we have this triangle here. We have these interior angles 1, 2, 3, and then you have the exterior outside of that would be B, and so on. So this is really a statement. It says triangles have interior and exterior angles. So we'd have this exterior angle here. If we had another line here, we'd have an exterior angle there. The theorem here says the measure of an exterior angle of a triangle is equal to the sum of the measures of two remote interior angles. Okay? So if we look at this here, we might have this angle, exterior angle on the outside, right? And then we could then say the measure of angle A, this one, plus the measure of angle B, this one, is equal to the measure of angle 1. Okay? Now, that's kind of what that theorem says. Now, if we looked at that, and so here's how this works. So I've added an angle here. Let's just say this angle is 35 degrees. And we're talking about this exterior angle theorem. And this general idea, measure of angle A plus the measure of angle B equals the measure of angle 1. And if we just look at this, we can kind of maybe understand it. So if we know what C is, it's 35 degrees. And we know the whole angle of this is equal to 180 degrees. And we have this line here, this straight line, and we know that it forms 180 degrees, right? So then this angle has to be angle 1, the measure of angle 1 has to be 145 degrees. And that makes it 180. So these two angles form 180 degrees. But also, if you remember, this plus this forms 180 degrees. So you'd know if this is 145, then these two angles together also have to be 145 to make this whole thing equal to 180. So that's kind of how this works. So if you know an angle in the exterior next to another angle within the triangle, that can help you figure out what the other two angles are equal to. So if we look at one last thing here, I know these notes are kind of long, sorry these are so long. But so now we're looking at corollaries, okay? And these are things that are kind of like theorems, but they follow as a result, or a direct result of another theorem. Okay, so let's just look at these. And they can be used as a proof here. And if you remember the first thing we looked at, the triangle sum theorem, this is lesson 4.1, and it's also theorem 4.1. We can have some corollaries that follow along with that. And really this triangle sum theorem just says the three angles of a triangle are equal to 180 degrees. Because that's true, we can also come up with the idea that acute angles of a triangle are complementary. Okay, and that means they're equal to 90 degrees. So if we just think about that, if we look at this thing here, so if you say, for example, if you have this triangle right here, and we say if the measured angle C is a right angle, so if this is a right angle, then A and B are complementary. They're also equal to 90 degrees. So if we have any acute angles within a triangle, then those have to be complementary or equal to a 90-degree angle. Okay. The one case that comes into view is where one of the other angles is equal to 90. So the whole thing is equal to 180. So no, these angles have to be less than the certain degrees, but they also have to be equal to 90 degrees when you add them together to give you the whole 180 degrees. So that's 4.1 corollary. The acute angles of a triangle are complementary. Okay, and then we look at this one here, the next one. This corollary 4.2 says there can be no more than one right or obtuse angle in a triangle. So we think about that. So, obtuse angle is equal to certain degrees, but right angle is 90 degrees. So we know if you have one right angle, 90 degrees, we know we can't have another one, right? Because that would give us 180 degrees between two angles already, and we still have another one to fill in. So then looking at the other way with obtuse, acute is something less than 90, obtuse is greater than 90. So, but then we look at obtuse angles. So if we have one that's, more than 90 degrees, it makes sense. You can't have any more obtuse angles in there as well. So that's kind of those two corollaries, and that should help you for the initial notes here. And if we look at this exterior angle theorem here, I just want to show you an example of a proof. I'm going to kind of show you that in another video. Maybe you can look at that in class. But I'll go through this because I don't want to make these notes any longer. Do your best to put these in your notebook and let me know if you have any questions in class.